Math Mentor back again with another lesson. In this video, I will be solving a question from the Cameroon GCE June 2014 Ordinary Level Mathematics Paper 2. This is a question on quadratic function involving parabolas and straight line graphs, and also the mathematical interpretation given to the point of intersection. Without wasting much of your time, let me dive right away into the question. June 2014, Paper 2, A. Given that y is equal to f of x, where f of x plus x squared is equal to x plus 2, construct a table of values of f of x for which x is greater or equal to negative 2 but less than or equal to 3. X is an integer. B. Taking 2 centimeters for 1 unit on both axes, draw a graph of y is equal to f of x. Using your graph, C, find the y value at the turning point. D, by drawing a straight line graph, solve the equation x squared minus 1 is equal to 0. To begin with, y is equal to f of x. So we need to make f of x the subject of the equation. Making f of x the subject, we obtain f of x is equal to negative x squared plus x plus 2. So this is a function we will be using for the range of values of x to obtain corresponding values of y. I will construct a table of values of x where I will use the function f of x to obtain corresponding values for y. On the first row, I will list values of x within the range, that is from negative 2 right up to 3. With each value of x, I need to evaluate negative x squared plus x plus 2, which is the function f of x or y. Beginning with negative x squared, I will square each value of x and then multiply by negative 1, obtaining negative 4, negative 1, 0, negative 1, negative 4, and negative 9. I then add x, obtaining negative 2, negative 1, 0, 1, 2, and 3. Finally, I add 2, and I obtain the following. Now, adding all the terms in each of the columns, I obtain the following corresponding values for y for that value of x. Bringing out ordered pairs in the form xy from the table, I will obtain negative 2, 4, negative 1, 0, 0, 2, 1, 2, 2, 0, and 3, negative 4. Moving on to the B part of the question, we have to draw the graph of the parabola using a standard scale given in the question. The scale is 2 centimeters to represent 1 unit on both axes. This means we count 2 squares and represent it as 1 unit. Of course, for the both axes. This is because GCE standard graph papers have dimensions of 1 centimeter square for each square. So we can safely use this graph to draw the parabola. Now, moving on to plotting the points that we obtained from the table, we proceed as follows. Negative 2 against negative 4, negative 1 against 0, which is the x-intercept, 0 against 2, which is the y-intercept, 1 against 2, 2 against 0, another x-intercept, and finally 3 against negative 4. I will then draw a smooth curve which will pass through all the plotted points as such. In question C, we need to use our graph and estimate the value of y at its turning point. The curve has a maximum turning point as we can see. To do this, I will draw a horizontal line from the maximum turning point to the y-axis and then read off the value at this point. We see that it meets the y-axis at this point. Recall that our scale is 2 centimeters to 1 unit. 2 centimeters has 10 subdivisions. This means that the value of one subdivision is 1 divided by 10, which is equal to 0.1. So the maximum turning point is y is equals to 2.3. D. Lastly, by drawing a suitable straight line from the graph of the parabola, solve the equation x squared minus 1 is equal to 0. You are required to solve this equation by drawing a suitable straight line from the graph. So I need to introduce the equation of the parabola into this given equation, x squared minus 1 is equal to 0. I have x squared minus 1 is equal to 0. First, I need to introduce a term, the first term, which is a term in negative x squared. So I add 1 to both sides of the equation and multiply both sides by negative 1, obtaining negative x squared is equal to negative 1. Next, to introduce the term in x, I add x to both sides of the equation, obtaining negative x squared plus x is equal to negative 1 plus x. Finally, I add 2 to both sides of the equation, obtaining negative x squared plus x plus 2 is equal to negative 1 plus x plus 2. Simplifying the right hand side, we have negative x squared plus x plus 2 is equal to x plus 1. The left hand side is the parabola f of x, and the right hand side is a straight line. So we are finding the value of x for which the two graphs are equal. Mathematically, we see the value of x where the two graphs intersect. So let's draw the graph of y is equals to x plus 1. We need at least 2 points to draw this graph. The intercepts are the easiest point to obtain. For the x-intercept, we substitute y equals to 0 into the function, obtaining x is equals to negative 1. So negative 1, 0 is the x-intercept. For the y-intercept, we substitute x is equals to 0, giving y is equals to 1. So 0, 1 is the y-intercept. Now, plotting these points on the same axis as the parabola, we have negative 1 against 0, which is the x-intercept, and 0 against 1, which is the y-intercept. Drawing the line, we see that it intersects with the parabola at the point where x is equal to negative 1 and x is equals to 1. Therefore, negative 1 and 1 are the values of x for which f of x is equals to x plus 1. And consequently, the solution of x squared minus 1 is equal to 0. You may verify your solutions by solving the quadratic equation x squared minus 1 is equal to 0. You will realize that the solutions are the same with what we have just obtained here. If this video has been of help to you, do me a favor by liking the video, subscribing, and leaving a comment about which topic you will want me to treat next. Thanks for watching.